Hi there, this is Dan from SolveBOTIcs, and this video will cover the Raspberry Pi base station I designed and built, or as I like to call it, the Mobile Command Center. This is a system that will work with a Raspberry Pi 4 or Raspberry Pi 5. So in 2022, I was doing what I normally do, and I designed the R22 robot. This is a platform that could be configured as a tank bot or configured as a four-wheel drive robot. The R22 has a Pi embedded in it that streams video from its night vision camera and drives the motors. This Pi that's inside the R22 receives commands from a second Pi, Raspberry Pi, that acts as the quote-unquote base station. The base station also receives the streaming video from an R22 robot and requires a monitor, a keyboard, mouse, power supply, and to control the robot, it also requires a video game controller. So this setup took up a lot of room, and moving it from one area meant gathering up the monitor, the mouse, the keyboard, and so on. And so this was a very cumbersome process. And after a while of doing this, I just decided I'd had enough, and I wanted to build something that could combine the Pi, the power supply, and all those components into one unit that was easy to set up and easy to take down. So if a thing is worth doing, it's worth doing well. I put a lot of thought into what I wanted out of the command center, and the qualities that are the most important to me are flexibility, reconfigurability, and reliability. So as I cover the different features of the command center, you'll see how they tie back to those three qualities. But the overarching theme for this command center is flexibility, because flexibility provides options, and much like having different tools inside your toolbox, having different options allows you to solve or fix a problem a lot easier. So the first area where I designed flexibility into the command center is in the power supply system. There's a lot to cover on this topic, so let me provide a real quick outline. First, I'll cover the input supply range, and then I'll lead into the different ways that you can use to power the mobile command center. Along the way, I'll be talking about some of the safety features that are designed into the system, and then I'll cover the hot swap capability, and we'll be providing a real-time demonstration of that feature. So let's start with the input voltage range. The command center can be powered from any power source ranging from 9.6 to 24 volts, and that's just an extremely wide input range, and that's the reason why there are at least 4 basic ways to power the mobile command center. So the first way is to use the included 12-volt power supply. This is the power supply that's included when someone buys the mobile command center. So wherever you have access to a 120 volt outlet, you will be able to use this power supply. And it provides 5 amps of current, so it can power a lot of demanding projects. So that's method number 1. If, however, you don't have access to a 120 volt outlet, or you don't want to deal with a cord, you can also power the command center using a rechargeable battery. So the command center has been designed to use an internal 12 volt nickel metal hydride rechargeable battery, and here's a better look at that. It's got 10 cells, and this form factor, the mobile command center has been designed to work with this form factor, and there's 2,000 milliamp hours of capacity. This battery can power the mobile command center for at least 3 hours. So let's say you don't have this battery available, or you don't want to use this battery internally. You can also power the mobile command center using an external battery, like this LiPo battery. You will have to make an adapter to go from this connector to either this Phoenix contact connector or the DC input, which is a 5.5 by 2.5 millimeter connector, but it can be done, and that offers a third method. Then finally, the fourth method that you can use is something like this. These are 8 AA batteries in a battery pack. This will provide 12 volts. And again, I'm using this, it's called a Phoenix contact connector. This will power the command center for at least an hour. This isn't as good as a power supply option as this nickel metal hydride that can power for 3 hours, but this, in a pinch, you can use commonly available AA batteries and power the command center. So I spoke a little bit about adapters. Let me cover sort of a safety feature that's been added to it, this power supply system. Also included with the command center is this what I call the charging adapter, but it's also just kind of like a general purpose adapter. This is included, and then there's an extra Phoenix contact connector. The idea here is that if you're connecting a different battery to it, you plug this in, and then on the adapter itself are markings, polarity markings, positive and negative, so that if you take your battery and normally the positive lead is the red one, the negative lead is the black one, you can then plug this in first, loosen the terminals, then use these markings to know where to plug the red lead in, where to plug the black lead in, or in other words, the positive and negative. And then when you disconnect it, now you have this perfectly connected connector that's ready to work with the mobile command center. So that's a safety feature. These are included so that every time you want to connect a new battery, you're assured that you can do it correctly. If for some reason the battery was had the incorrect polarity and it has like a reverse voltage, what would happen? What's going to happen if you connect a reverse voltage to the command center? So that's a second safety feature. So this is the circuit board that's used in the mobile command center, and for each of the inputs there are three. There's the DC input. That's this guy. He goes in there, and then there's these two different battery connectors. For each one of those, there's a reverse voltage protection diode. So if this were wired backwards, it'll be plugged in there, and when the switch is turned on, absolutely nothing will happen, and that's by design. The diode, if it gets the reverse voltage, it just will never conduct. It will never conduct that electricity, which will never reach any of the sensitive electronics in the mobile command center. It just stops it before it can do any damage. So that's sort of like a passive safety feature that's been designed into the circuit board of the mobile command center. That's the bulk of the power supply system, but there's one more feature that I'd like to discuss and actually demonstrate in real time, and that is the hot swap capability. So I'm back and I'm ready to talk about the hot swap capability and to provide a real-time demonstration. So by hot swap capability, I'm referring to being able to switch from running the command center from a power supply such as this 12-volt rechargeable battery to this 12-volt power supply without having to power down the command center at all. So imagine a scenario where you're running a critical operation that you cannot stop, you cannot interrupt it. However, you notice that your battery voltage is getting lower and lower, and that you're going to have to switch to another supply source soon. With the hot swap capability, you can make that switch and continue running. So I've described this on the blog and I cover it in the user manual, but I believe this video demonstration will probably do the best job of describing exactly how this works. So let's begin. So I'm going to set up the scene here. I'm going to play a video, and that's going to represent the critical operation that cannot be interrupted. Play that in loop mode. Okay, and so now we are running our critical, quote-unquote, critical operation, and I'm running off a 12-volt battery. I look up and I notice my supply voltage is dropping, and let's imagine it's down to 8 volts. I am going to have to switch soon. So I grab my 12-volt power supply, I plug it in, I plug it into the 120-volt outlet, and I make sure that it's operational. Now I can come in here and I can disconnect my battery. I can now take this battery and go recharge it because I'm currently running off of a 120 volt outlet. Mobile Command Center still stayed up and running and literally did not miss a beat. Okay, some time passes and I notice that there's a severe weather on the horizon and we may have a power outage and I'm going to lose this power supply system. Well, what I can do is if I have a second one of these batteries, I can plug it in. If this is fully charged, I can plug this battery in and we can now see that it works the other way too. I can switch from this power supply system to the battery and the Mobile Command Center automatically and seamlessly switches from this power supply to this one and still stays up and running. And my critical operation is still continuing. Okay, so what happens if I'm running low on this battery? Well, I can power it from this external battery. So I have an adapter made where I can go ahead and plug this in. And now I'll plug this in. My critical operation is still running. I can disconnect this battery now. Now the Mobile Command Center is being powered by this LiPo battery, and this will buy me some more time. The critical operation is still continuing. Let's say it's still not complete, and there's still bad weather. I'm still not able to use the 120 volt outlet, and this battery is now finally starting to drain. What do I do? Well, remember this will still provide at least one more hour of charge, so I can plug this in. Now that gives me the ability to switch from this one to this one, and this will probably run for at least an hour. And all throughout those power supply switches, as you just saw, my critical operation was able to continue. I did not have to power down every time I made a switch. So now we reached the end of our critical operation and it's complete. It's done, and the Mobile Command Center is still powered on. The storm has passed, regular power is restored. I can now plug that in and watch what happens to this voltage as I do that. It automatically jumps up to the highest voltage. And that is a real-time demonstration of the hot swap capability. A very useful feature of the Command Center that can actually help you solve any power problems. Okay, so I began with the features by talking about the power supply, and I covered that in great detail. Now I'm going to continue talking about the rest of the features of the Command Center, and I'm going to go in basically a clockwise fashion. So you may be wondering, why do I have this system up? Well, I'm in the middle of a build, and I thought this would actually give me a good opportunity to talk about the reconfigurability of the system. So let's begin. So to begin with, the Ethernet port is brought out. It just connects to the Ethernet port of the Raspberry Pi, whether it's the 4 or the 5. Next are the USB ports. So by default, I bring out the USB 3.0 ports of the Raspberry Pi 4 or the 5. But if you wanted to connect these to the USB 2.0 ports instead, that's where the system exhibits reconfigurability. So if you wanted to do that, you would start by removing these bolts and taking the bezel off. Loosen those bolts to remove the bezel. Now you have access to the underplate. There are 6 bolts that are holding this to the rest of the Command Center. You start by loosening these bolts. Use something soft like foam to protect the monitor. And then what I like to do is grab another object to use as sort of like a third hand. And so this underplate, I call it, will now be able to move forward. And I use this object, like my robot, to kind of let it rest gently on there. Now I have the power meter, the switch, RPi power, the cooling fan power, and then there's a keyboard connector down here. What I can do is I can disconnect these. And now this entire assembly is able to be removed, and this is sort of like a modular design. Okay, so that's been moved out of the Mobile Command Center. I can move these objects out of the way now. Put down some protective foam. And here's the underplate with all the components mounted to it. I can now access the Raspberry Pi. So in this case, I'm running a Raspberry Pi 5, but those USB ports that I had connected to USB 3.0, I can now move them around, move them to the USB 2.0 if I so desired. Also, I can add anything to the GPIO rail here and put this back in. So that's just an example of how it can be reconfigured and how this is built to be sort of modular. So this is designed so that I can get in here often and be able to add or remove hardware as needed. So that was another requirement. So I get back in here and I'm able to reconnect the power supply meter. This middle connector here is where the power switch is connected. Then I connect the Raspberry Pi power and the cooling fans. That's what these are. It really doesn't matter the order, but I do like to keep it straight. So these bottom two USB connectors are for the cooling fans, and this top one is for the Raspberry Pi. Finally is the final connection here is the keyboard connector. And there it is. As you push this back, just make sure that these clear this edge here. Just push them down gently and guide it in. Okay, so just gently push. Make sure that's seated all the way in there. When it is, then it's time to give it a final tightening. You don't want to over tighten these. There are brass inserts. If you tighten them too much, you might actually pull them out. But not a lot of force is really required to hold this in. So you just need to, just enough to secure everything. With that in place, it's time to put the bezel back in. And again, just gently move it into place, and you'll hear it snap into place as you push around the edges. At that point, you're ready to put in the M3 by 6mm screws around the periphery and put your panels back on, and these panels as well. Okay, so we're back now with the original system, and at this point we've covered the power supply system, the Ethernet port, and the USB ports, and we've seen how it can be reconfigured to use different USB ports or even switch from the Raspberry Pi 4 to the 5 or vice versa. Next, we move on to the power switch, and there's not much to say here other than it's just placed in close proximity to the voltage and current meter. The voltage and current meter is useful because as an engineer, I always want more data. So it's good. It's useful for me to see how much current is being consumed when the mobile command center is sitting idle like this. Or if you're doing something like running a stress test, it's nice to see how much current will be consumed by that or any other project. Next up is the display. This is a 10.1 inch display with touchscreen capability and built-in sound. So there are speakers behind this screen, and you can use the keyboard function key to increase the volume or decrease it. So this system can be used with a wireless mouse or a wired mouse, but you also have the ability to just rely on the touchscreen capability as well. Moving on, our next item that ties back to reconfigurability, and that would be these panels. So we have an exhaust panel here. That's in place because there are two cooling fans, and it's good to have the airflow move across the back of the unit. So this is always a requirement. There should always be an exhaust panel in there. But then you have this blank panel, and this blank panel can be thought of as sort of like a blank canvas. It can be removed. These can actually be switched. You can change the position of them. But this panel is basically a blank canvas, and you can add hardware or remove hardware, or you can even make up panels to have different pieces of hardware so it can support different projects. So recently I designed and developed this panel. This is a status display that can plug into this mobile command center. And what this will do is it will display the IP address, the CPU temperature, the RAM usage, and the disk space. So this is an example of what I mean by blank slate, where you can customize these and add or remove hardware. So I'm going to switch to another system that actually has this in place. Okay, so I'm back again, and this time I've got the mobile command center powered up, and I switched from that blank panel to a panel that's been designed to have a status display in here. So here's a close-up of that status display. We can see that it's displaying the IP address, the CPU temperature, the memory usage, and the remaining disk space. So this is just a prime example of how you can go from a blank canvas like this to creating a custom piece of hardware like this, and it just further illustrates the reconfigurability of the mobile command center. So the idea with the panels continues on, and you have these larger panels, and it's the same idea. You can add or remove hardware on these. You can customize them. But behind this particular panel is the SD card. So right now I am running a 64-bit operating system for the Raspberry Pi, but since I have this, I can try out different operating systems, and this is where I would switch out the card. Okay, so this idea of having panels that are reconfigurable continues on down even to the bottom part of the mobile command center. So I have these here, and the idea here is that when I control a robot, I use a video game controller, much like this one, and it plugs into the USB port. I may want to, one of these days, take the joystick and the buttons and just take them and perhaps remap them to this area. So that's what that provides for me. That it provides that flexibility or that option to be able to take one of these controllers, remap it to this area. I may or may not do that, but it's always nice to have that option. So then the next, or the final feature here, is the keyboard. For this, I wanted a good sized keyboard. I've seen different builds where there's like a really small keyboard. I like this one because my fingers can find the keys quite easily. I don't have to try to use like a little toothpick or anything to get at the keys. But because it does take a large amount of real estate, I thought it would be a good idea to provide storage underneath this keyboard. So I modify this keyboard slightly. I custom make these washers out of sheet metal, and then where these washers are, there are rare earth magnets that will keep this in place. If you're taking this and you're putting it into a vehicle that's maybe going over bumpy roads or it's going off-roading, when I ship these, I do have a Velcro strap that will loop through here and come down here, and it'll just keep this keyboard in place. I put that in there to keep this safe during shipping and so the keyboard won't pop out. These magnets provide a lot of force, but if there's a sudden jarring impact, they can only do so much. The keyboard probably will come loose in that event. So there's a Velcro strap that I'll have when these are shipped out. If you know you're going to be using this in a vehicle that will be going over bumpy roads, it's probably a good idea just to continue using that Velcro strap. So back to the storage area. I have the storage area underneath the keyboard, and this is sort of like a toolbox that comes with it. There's a charging adapter in there. There's a wrench to be able to take these screws out, and another adapter and an extra connector. That fits in there. But you can use this space for however you see fit. If you're someone who likes to experiment with different operating systems, you can store extra SD cards in here. Or if you have a wireless computer mouse that fits, you can go ahead and use one of those here. So there again is another way that ties back to flexibility and reconfigurability. Okay, so the final feature I want to talk about is the build quality or the reliability. So an example of that, a very good example of that, would be these power meters. When I received these for the build, they come with these crimp connectors. So when I get these, I just take these and I put them in a junk bin. And instead, I'm not going to use those for anything I care about. So instead what I do is I will solder tin these terminal connectors, use solder flux, get a good coat of solder on there, and then take my cabling, do the same, and then provide a very good solder joint, then use heat shrink tubing to get a very reliable connection. And so that's an example of the build quality, but that lends it to being more reliable. You won't have to worry about this disconnecting the same way you would if I were to use these crimp connectors. I just throw these away and I just do something better like soldering it. So that's true for the power supply meter. That's also true for the power supply switch. Anything that needs that type of connection is going to get soldered, and it's going to be soldered with flux to get a nice reliable solder joint. I covered quite a lot in this video, but if you'd like to know even more about the Command Center, you can also check out my project blog at SolveBOTICS.com. There you'll find user manuals and other resources. The Mobile Command Center is also available to buy from my Etsy store. Check out both links in the description. Thank you for watching and have a great day.